All right, so this lesson is on horizontal asymptotes. So your very last question on the quiz is going to talk about this. It's going to talk about rational functions, vertical asymptotes, horizontal asymptotes, that sort of thing. So this will be definitely used in the last quiz question. So what is a rational function? So we've had rational expressions. We've worked with those in rational equations. And what makes something rational is that you have a fraction with variables in the denominator. So a rational function is specifically a function, meaning there's one output for every input, and it will have a fraction with variables in the denominator. So that's what we call a rational function. So the top and the bottom of the fraction are typically polynomials. So you usually need to factor them in order to work with rational functions. So rational functions have these things called asymptotes. And so these are lines, either vertical or horizontal, sometimes slanted, that the graph gets really close to, but doesn't actually touch the line. So it starts to kind of follow that line and starts to look like it's straight, but it never actually is straight. So we've got vertical, horizontal, and slanted asymptotes, and this is called the behavior of the function. So rational functions always have vertical asymptotes. So there's always a spot where the graph looks like it's going straight up and down. And this is where the denominator is equal to 0. Sometimes they have horizontal or slant asymptotes. Sometimes they don't. So you always have a vertical asymptote, but you don't always have one of the other types. So I'm focusing on the horizontal asymptotes today. So this is where your graph looks like it's going horizontal or straight across. So that's what a horizontal asymptote is. And so there's going to be some point where the graph starts to just look like it's straight, kind of going horizontal. And so it's going to be a y value that it's approaching. So vertical asymptotes are asking what x value are you looking like you're straight at. Horizontal asymptotes is asking about the y value. What y value are you looking like you're straight at? And so you can't cross a vertical asymptote because that would mean you're dividing by 0, but you can cross a horizontal asymptote. So it's possible that your graph goes through a horizontal asymptote and then flattens out. So this is how it's slightly different from a horizontal or a vertical asymptote. So there are 3 different cases where we're looking at here with the horizontal asymptote. And we're looking at your highest exponent, basically. The highest exponent on the top and then the highest exponent on the bottom of the fraction, the exponent that's on your variable. So that's the degree of the polynomial. So we're caring about that highest value. And so if the number on top, the exponent on top, is larger than the exponent that's on the bottom, there is no horizontal asymptote at all. So that's your first case. So if you're asked to find the horizontal asymptote, you would say none. The second case is when the number on the top, that degree, that highest exponent, is equal to the highest exponent at the bottom. So they're the same. No, I got these reversed. Sorry. I'm reading this. I'm like, wait a minute, that's not the case. Oops, I did not mean that color. I have these backwards. This should be less than, and then this is when they're the same. Okay, so when the top is smaller than the bottom. So the highest exponent on the top is smaller than the highest exponent on the bottom. Your horizontal asymptote is always going to be 0, y equals 0, which is the horizontal axis. The third case is when they're equal. And when they're equal, your asymptote is based off of the coefficients in front of these terms. You just take those coefficients and that is your horizontal asymptote. So it's going to be a fraction, or sometimes that fraction reduces to a whole number. But that's when they're equal. The degree on the top is equal to the degree on the bottom. So there are three cases for finding the horizontal asymptote, and they involve minimal math to determine what they are, which is great. With the vertical asymptote, you had to go and like solve these things. When you're finding a horizontal asymptote, you really don't have to do much at all. There's either none, it's zero, or you're just looking at your coefficients and then reducing the fraction. So really simple. So here, our first example, we've got this rational equation or function. We've got 8 over x squared plus 4x plus 4. So we need to determine what case are we in, what is the horizontal asymptote, if there is one. So on top, there is not an x. So notice that the top is just a number. So if there's no x at all, then the degree, that number n, is 0 because there is no variable there. So we say that is 0. The denominator, the highest exponent, is 2. So your degree is 2. We're using m in this case. So when you're comparing these, 0 is smaller than 2, so n is less than m, because the top is 0, bottom is 2, the top is smaller than the bottom. So that is case 2. When n is less than m, your horizontal asymptote is y equals 0. So I always abbreviate horizontal asymptote as HA, so it's y equals 0. So nice and simple. You just have to determine what n and m are, and then you look at the chart. So really nice. Now, a second question here is, if there is a horizontal asymptote, we want to determine where the graph crosses it, if it does. It doesn't always cross the horizontal asymptote, but if it does, we want to know kind of where that would occur. So if you're asked to find out where it crosses the horizontal asymptote, you're basically saying, well, where is our graph equal to that y value? So you set your function equal to your horizontal asymptote. Which is 0. And then you're going to solve. So this is the part where you do have some math to do, but it's usually not hard math at all. It's, you know, it's probably one of the easiest things that you have to do this week. So when we're solving something like this, you want to get rid of the denominator. So you're going to be multiplying both sides by the denominator, because we want to get rid of the fraction. That's what we do. So we multiply both sides by x squared plus 4x plus 4. And we are allowed to do this because the denominator is never allowed to equal 0. So we're allowed to multiply those both sides. And that basically cancels out your denominator. So you get 8 on the left. And then on the right side, 0 times anything is 0. So we get 8 equals 0, which is false. So that tells us that the graph does not cross the horizontal asymptote, because we get something that's false. So that's why it says if any, because sometimes it doesn't cross that point. It won't kind of, you know, touch it.
So when you get a number a smaller number on top without an X or anything, it's gonna always equal out to 0.
Yes. Yeah, that value for the degree is always going to be 0.
Okay.
There are other questions. I'm going to graph this because I think a lot of rational function stuff, like it makes more sense when you see it graphed, because then you can kind of understand what you're looking at. So I'm going to just type in our function right here into Desmos. So I've got q of x equals 8 divided by x squared plus 4x plus 4. So I'm going to just kind of zoom out here. This is what our graph looks like. And the horizontal asymptote is where it looks like it's going straight horizontally. So you can see that it basically looks like it's on the horizontal axis where it looks like it's starting to become straight. And so I can kind of zoom in here and it's getting really, really close to it, but it never actually gets there. But if I graph y equals 0, that is our horizontal asymptote. You can see it's getting really close to it, but it doesn't actually touch it. It will never actually cross that point. So the horizontal asymptote is the value it's getting close to, where when it starts to look like it's going straight, but not quite. So you can double check your work by graphing your function and then putting in your asymptote, your horizontal asymptote, and seeing it, does that look like it's where it's basically becoming straight? And when you zoom out enough, they will look like they're on top of each other, which tells you you've got the right number there. But we'll never actually touch that value. We'll just get really, really close to it. So that's example here. We've got the degree of the top smaller than the degree on the bottom. So here's another one. We've got r of x equals -4x squared plus 5x minus 1 over x squared plus 2. So the highest exponent on the top is 2, and the highest exponent on the bottom is also 2. So we have an x squared on top and an x squared on the bottom. So these values are equal to each other. So that puts us at case 3, where you're looking at the coefficients. So that is the numbers in front of your x squared terms. Oops, wrong one. So your horizontal asymptote is in front of the x squared on top, we have a -4. And then in front of the x squared on the bottom, we don't have a number, so we put a 1. So you basically, -4 divided by 1 is equal to -4. So our horizontal asymptote is at -4. So at y equals -4, it's going to look like it's going straight. So when the top is equal to the bottom, you're just looking at the numbers in front of those x squared terms, and that gives you your horizontal asymptote. So we do have a horizontal asymptote. So now we want to see, does our graph cross that point? So like we did in this, the first example here, you set your equation, your function equal to the horizontal asymptote. So I have -4x squared plus 5x minus 1 over x squared plus 2 equal to -4. And then just like the previous example, we multiply both sides by the denominator so that we can get rid of that fraction. So I'm going to multiply both sides by x squared plus 2. And that cancels out the fraction. So I have negative 4x squared plus 5x minus 1. And on the right, I need to distribute here. Negative 4 times x squared is negative 4x squared. And then negative 4 times 2 is negative 8. So we're trying to find, is there an x value where we're crossing the horizontal asymptote? So we're solving for x here. And so if you have a quadratic, if you have something x squared, you need to put everything all on one side. So I'm going to start by adding 4x squared to both sides. So I'm going to move the x squared on the right to the left, just I like to have mine on the left. And notice when we do that, we have a negative 4x squared plus 4x squared. That actually adds up to 0. So our x squared disappears completely. And so I have 5x minus 1 equals negative 8. So now I'm solving for x here. I have a linear equation. So I need to get x by itself. So I'm going to add 1 from the left, and I'm going to move that negative 1 to the right by adding that 1. So I'm going to put plus 1 on both sides. That gives me 5x equals negative 7. And then we want x, so we're going to divide both sides by 5. And negative 7 divided by 5 is going to give us a decimal. So we're going to leave it in fraction form. X equals negative 7 over 5. So that is where we are crossing the horizontal asymptote. So this graph is actually going to cross our horizontal line at that particular point. So it usually goes through it and then kind of starts following it again. So before I show the graph and what this looks like, visually, do you have any questions on the algebra here?
Yes, how did you get the 7/5?
So the negative 7/5 comes from when solving for x, that's right here. So I had to divide both sides by 5 because I want to get this 5 gone. Yeah, so then the 5 divided by 5 is 1, so that's why I have just regular x, and then we've got this fraction on the right.
Okay.
Other questions? Okay, so I'm going to bring up this graph. And our horizontal asymptote is now at negative 4. So I'm going to just kind of zoom out. So that's our asymptote. And so I'm going to graph this function. Okay, so this is what this one looks like. So I'm going to just turn off the asymptote right now. So our function r of x looks like this. And when you zoom out, it looks like it's starting to get straight at this point right here. When you zoom out, you can see it looks like it's just becoming a straight line. So that is at negative 4. So you can see when I graph y equals negative 4, the horizontal asymptote, it lines up with where it looks like it's going straight. You can see that they kind of overlap once you get really far out. Now notice that we actually cross this point. I'm going to make this dash. So our graph, which is the green, actually crosses this point, goes through the horizontal asymptote right here, negative 1.4. That is equal to negative 7 over 5. So if you put negative 7 divided by 5 in your calculator, you get negative 1.4. So it crosses the horizontal asymptote right here, and then it starts going back up and start getting closer and closer to it. And then it doesn't cross it again. It just kind of stays underneath it, but gets really close to it. So vertical asymptotes, you can't cross, but you can cross horizontal asymptotes, and that's what happens here. So it kind of goes through it, and then it gets back up, and it kind of gets close to it. And on the right side here, you can see it's getting really close to it, but it will never cross it because we only solved and found one point where it crosses that horizontal asymptote. Are there questions? Okay. Here, now we've got x cubed minus x squared plus 1 over 2x minus 3. So on top, the highest exponent is 3. And in the bottom, on the bottom, we have an x. There's no exponent, but there is a variable. There's one x there, so your degree is 1. So if it's linear, if there's no exponent on the variable, it's a 1. So we have the top is larger than the bottom. So when that happens, that is case 1. There is no horizontal asymptote. So your horizontal asymptote, you just write none. There isn't one at all. And so if there's no horizontal asymptote, there's no point that it's going to cross. So we don't have to do the thing on the right. We don't need to find out, where it's crossing because there isn't one. So graphing this one, turn that off. We've got nx equals cubed minus x squared plus 1, 2x minus 3. So I'm going to zoom out, and there's no horizontal asymptote. There's no place where the graph looks like it's going horizontal, where it's going straight across. There's places where it's going vertical, but there's no place where it's going straight horizontally. So that's why there is no horizontal asymptote. So you can verify with the graph. If there's no place where it looks like it's going straight line across, there's no horizontal asymptote. Are there any questions? All right, one more example here. So we have s of x equals x plus 3 over 2x squared minus 3x minus 5. So on top, we have x plus 3. So we have an x with no variable, so that's going to be equal to 1. I mean, no exponent, not no variable. We have a variable. So n is equal to 1. And then in the denominator, our highest exponent is 2. So we've got n, the top is smaller than the bottom, because 1 is smaller than 2. So when the top is smaller than the bottom, that is case 2, where the horizontal asymptote is at y equals 0. So our horizontal asymptote is y equals 0. So we have a horizontal asymptote, and now we want to see, do we cross that horizontal asymptote? So the first example that we did where we had y equals 0, we did not cross the horizontal asymptote. So do we cross this one? So you take your graph or your equation here, and you set it equal to the horizontal asymptote, which is 0 in this case. And just like the other examples, you multiply both sides by the denominator. So that will cancel out that fraction. So that cancels out. And so we're left with x plus 3. And then 0 times anything is 0. So the first one we did, we got a contradiction. We got 8 equals 0, which meant that it did not cross because we got something that was false. But here we have something we can solve for x. So I can keep going. I can subtract 3 from both sides. So I'm going to solve for x. And that gives me x is equal to -3. So that means we are crossing the horizontal asymptote at -3. So this one, just like the one before it, does, or not the one before it, which was the other one that I crossed right here. So this one we crossed the horizontal asymptote. This one we're also crossing the horizontal asymptote. So if I bring up the graph, our horizontal asymptote in this case is 0. And then our function is x plus 3 over 2x squared minus 3x minus 5. So you can see there is a horizontal asymptote because it looks like it's going horizontal right on the x-axis. And you can see, it's kind of hard to see because I made that dash. Let me make this solid again. Oh, come on. There we go. You can see when it's solid that yes, it's basically right on top of the graph. You know, that's where it's going straight. And we determined that it does cross at x equals -3. So I'm going to zoom in so you can see that. So it's really hard to see, but you can see right here at x equals -3, we kind of went through and we go through the horizontal asymptote. And then we start flattening out again. So we do cross it right here at -3, though it's very difficult to see if you're zoomed out too much, which is why we want to be able to solve this with algebra, because if you try to do it on the graph, you may not be able to see that. And on the right side, we never cross it. It always stays above, but it gets really close to it. So this one, we do cross that horizontal asymptote, and we do so at -3. There any questions?
Whew.
Okay. So that's horizontal asymptotes. You can see it's really not bad. We really didn't have to do a lot of math here. And on the quiz, you do not need to do the right stuff or the stuff on the right side where it asks you where it crosses. We're not requiring that on the quiz. I just was doing that to kind of show you some math here. On the quiz, you're only going to be asked to basically find the horizontal asymptote, the left side. So the left side is all you're going to be asked to do. And you can see the work is very, very minimal. So this will be the very last question on the quiz is going to be about rational functions. You'll be asked to find the vertical asymptote, the horizontal asymptote, if there is one. So at least with the horizontal asymptote, the work is very minimal. It, really shouldn't take more than 30 seconds as long as you have your notes handy, because all you really need is this slide right here to determine what the horizontal asymptote is. So at least that aspect of the quiz, that will go really quickly.
Okay. And like on the quizzes, like you, I thought that I can go back into the quiz, but I can't, like 1 through 4.
Yeah, once you've taken the quiz, you can't retake the quiz. You can open it up and look at your scores, but you can't retake the quiz.
Like to do the quiz for show on in the quiz work.
Yeah, so the quiz work, you want to make sure that you're doing that at the same time that you're doing the quiz so that you can turn it in after you finish the quiz, but you can't go back and retake the quiz and make more quiz work.
And so like they said, that will have to be done for me to be counted present or something.
It's the quiz work is how your quiz score gets counted in the grade book and how you get partial credit if you have some work that's correct, but you didn't get the answer right, but maybe you have part of it correct. That's how you get partial credit for those problems.
Okay, but it won't show up like I wasn't present. Like it said something about you had to be done to show your present or something in like in this term.
For participation, that for the SI policy where you have to submit work or don't go 14 days without submitting work or you get withdrawn. Turning in quiz work counts for that. Taking the quiz counts for that. Any work that you do in the class will count as that participation.
Okay. Because I was thinking I can go back and do the quiz work, but
No, you want to do it at the same time that you're taking the quiz and then turn that in afterwards.
okay.
Any other questions?
No, I'm still trying.
Great. Yeah.
I have a headache, but I'm still trying.
Yeah, I mean, trying is all that's all I ask, is that you don't give up on the class. You try, you go through the work. Weeks 7 and 8 are typically easier than weeks 5 and 6. So
Okay.
yeah, so things should be, I mean, like this is like the start of like, oh, this isn't so bad. This wasn't, you don't really have to do a lot with the horizontal asymptote. And people do find the last 2 weeks of class easier than some of the previous weeks, which is nice because then you're kind of, ending on an easier note. So.
Okay.
All right. Well, I'm going to let you guys go so you can, do whatever you were doing on your Sunday, whether it's, doing your discussion or working on some work. I'm going to post the recording hopefully within the next hour and email it out to everybody. So that way, if you need to reference this or, you want the PowerPoint, you'll have access to that.
Okay.
So thank you guys so much for coming.
Thank you.
Yep. Take care. And I will see you guys next week, which next week will be at noon, not 3 o'clock, because I do have something. I have a wedding that weekend. So noon next week. Next week, Sunday will be at noon.
Okay.
All right. Take care.
All right.
Bye.
Bye-bye.